Hi, I'm Pat Kelly. Okay, in this problem, they give us this u vector and this v vector, and the directions are to evaluate the expression that they give you. Okay, and you can see that ours involves a cross product, but it also has that scalar multiple, which I want to address first. Let's get that out of the way. So you know how to do a 2 times u vector. You just multiply that 2 through to each of the components. So I'll have a 6i minus 2j and then plus 4k. All right, now let's focus on that cross product. To set up your cross product, what we have is kind of like a nifty little algorithm where what we do looks like a determinant and it's not technically a determinant, but what it does is it capitalizes on your understanding of how to evaluate a determinant in order to get that cross product. Here's what it's going to look like each time. Is your setup will be I, j, and k, the vectors, across a row, the first row. And then each of the other rows will be your components from the vectors that you're trying to find that cross product of. So the first one here is 2u, which we did our work up here. So across the second row, I'm going to write just the components, 6, a minus 2, and then the 4. And as your bottom row, you're grabbing the components from your other vector, v for us in this case, and my components of 2, 1, and minus 1. And as I said, it follows the like the mechanics of a determinant, so not technically a determinant, but if you follow through with your cofactor expansion type of approach, your answer is going to be the cross product that we want. Okay, so when I do my cofactor expansion here, I'm going to grab that I vector. I'll leave a space for a second, because what that multiplies by is the determinant of the submatrix, in this case right here. So minus 2, 4, 1, minus 1. And that's going to be a true determinant. Minus, because I'm still doing my cofactor expansion, so as I move over to the right, I need to make that a negative. And then my j vector. And the determinant here of the submatrix, which is going to look like a 6 over here to the 4, back down to the 2, and then over to the negative 1. You're skipping that middle column because that's where the j is. I'm multiplying by the j. Okay, almost done with the setup of our cofactor expansion. Now I go over and get the k vector, leave a space again. And my submatrix this time, covering up the k column, 6, negative 2, 2, and 1. Okay, so let me just slide down now and start doing my work. In each of those little submatrices, you do your crisscross patterns. So let's see what we're going to have here. Negative 2 times negative 1 would be positive 2. Subtract 4 times 1, which is 4. And that's going to multiply by the I vector. I still have this subtraction. And then my crisscross pattern this time is going to be 6 times the negative 1 is minus 6. Subtract 4 times 2 is the 8. And that's going to multiply by this j vector. Plus, and then the crisscross pattern for our last little matrix is 6 times 1 is 6. Subtract. Negative 2 times 2 is negative 4, so that's going to become a plus 4 times that k vector. I think I can finish in one step here if we just do some arithmetic, right? Negative 2i minus, and that's actually a minus 14, so that'll become a plus 14j. And then plus 6 plus 4 is 10k, and you're done. All right, that's your answer. Practice them on your own.